Algorithm. As we know that a program is a collection of instructions, the language used to write a program is called a programming language. Before writing a program on the computer, every programmer must analyze the problem and write an algorithm to solve the problem. An algorithm is a set of steps in a sequential manner to solve a problem or to complete a task. The problem can be logical or mathematical. Algorithms are the building blocks of computer programs. They are important to programming as recipes are for cooking. An algorithm is always written in very simple words and precise language so that the steps can be understood easily by everyone. In computer terms, algorithm is the sequence of steps or computer operations which collectively solve a given problem. Characteristics of a good algorithm. The main characteristics of a good algorithm are precision. Each step is precisely defined. Uniqueness. Result of each step should be uniquely identified and only depend on the result of the preceding step. Finiteness. It should stop after a finite number of instructions are executed. Input. It should have well-defined input. Output. It should have well-defined output. Effective. It is measured in terms of time and space. Uses of an algorithm. Algorithm is commonly used for performing data processing, performing computer and mathematical operations, manipulating data, searching for a particular data. Writing an algorithm. The construction of the algorithm is the stage which requires creative thinking and finding the best possible combination of steps to get the result. For example, A. Algorithm to find product, sum and difference of two numbers. Step 1. Start. Step 2. Read two numbers and store them in A and B. Step 3. Multiply two numbers A and B. Step 4. Print the product. Step 5. Add two numbers A and B. Step 6. Print the sum. Step 7. Subtract the number B from the number A. Step 8. Print the difference. Step 9. Stop. B. Algorithm to find the smallest in two numbers A and B. Step 1. Start. Step 2. Read two numbers and store them in A and B. Step 3. Compare number A and B. If A is less than B, print A is smallest and go to step 5. Step 4. Compare number A and B. If B is less than A, print B is smallest and go to step 5. Step 5. Stop. Defining flowcharts. A flowchart is a type of graphical diagram that represents an algorithm. It is a set of instructions that can be followed to perform a specific task, workflow, or process. This diagrammatic representation illustrates a solution model to a given problem. Flowcharts are used in analyzing, designing, documenting, or managing a process or program in various fields. Flowcharts show the sequence of instructions in a single program. They play a vital role in the field of programming. These are helpful in understanding the logic of complicated and lengthy problems. Once a flowchart is drawn, it becomes easy to write the program in any high-level language. Often we see that flowcharts are helpful in explaining the program to others. Hence, it is correct to say that a flowchart is must for the better understanding of a complex program. Symbols used in flowcharts. Different symbols are used to draw different types of flowcharts. Let us discuss them. Name, symbol, description. Start/stop. It is used to show the start and stop points of the flowchart. It usually contains the word start or stop. Process. It shows a process or action step. This is the most common symbol used in flowcharts. Decision. It indicates a question or branch in the process flow. It is used when there are two options, within brackets, yes/no. Input/output. It represents material or information entering or leaving the system, that is, input and output. Flow line, within brackets, arrow, comma, connector. It shows the direction in which the process flows. Connector, within bracket, inspection. It is used as a connector to show a jump from one point in the flowchart to another. Connectors are usually labeled in pairs to show matching jump points. Rules to draw flowcharts. You must follow these basic rules while drawing a flowchart. The flowchart should be clear, neat, and easy to follow. Maintain the direction of the flow from left to right or top to bottom. Only one flow line should come out from a process symbol. Ensure that only one flow line should enter a decision symbol, but two flow lines should leave the decision box. Ensure that the flowchart has a logical start and end. Advantages of flowcharts. Flowcharts provide following advantages. It provides a better understanding of a problem. It facilitates a programmer to analyze the problem in detail. Let us understand how some simple flowcharts are made. Example 1. Flowchart to drink a glass of cold water. Start, go to the kitchen, take a clean glass, take out a water bottle from refrigerator, pour the water into the glass, drink the water, clean the glass, fill the bottle and keep it back in the refrigerator. Stop. Example 2. Flowchart to calculate simple interest. Start. Read P for principal, R for rate, T for time. Calculate SI is equal to, within brackets, P star R star T /100 close bracket. Print SI, stop. Example 3. Flowchart to add first 100 natural numbers. Start. Sum is equal to 0. N is equal to 0. N is equal to n plus 1. Sum is equal to sum plus n. Is n greater than or equal to 100? Yes. Print sum. Stop. Is n greater than equal to 100? No. N is equal to n plus 1. Sum is equal to sum plus n. Is n greater than equal to 100? Yes. Print sum. Stop. Example 4. Flowchart to find greatest of three numbers. Start. Enter three numbers A, B, C. Is A greater than B? Yes. Is A greater than C? Yes. Display A. Stop. Is A greater than B? No. Is B greater than C? No. Display C. Stop. Is A greater than B? Yes. Is A greater than C? No. Display C. Stop. Is A greater than B? No. Is B greater than C? Yes. Display B. Stop. Solving problems using algorithms and flowcharts. Example 1. Write an algorithm and draw a flowchart to calculate the factorial of a number. Algorithm. Step 1. Start. Step 2. Read the number n. Step 3. Initialize I is equal to 1. Fact is equal to 1. Step 4. Check if I is less than or equal to n. Then repeat step 5 to 6 until I is equal to n. Step 5. Fact is equal to fact star I. Step 6. I is equal to I plus 1. Step 7. Print fact. Step 8. Stop. Flowchart. Start. Read n. I is equal to 1. Fact is equal to 1. Is I less than or equal to n? True. I is equal to I plus 1. Fact is equal to fact star I, stop. Is I less than or equal to n? False. Print fact, stop. Example 2. Write an algorithm and draw a flowchart to check whether a given number is even or odd. Algorithm. Step 1. Start. Step 2. Read number. Step 3. Check if number %2 is equal to 0. Then print within inverted commas number is even, else print within inverted commas number is odd. Step 4. Stop. Flowchart. Start, read a number. Is number %2 equal to 0? Yes, number is even. Stop. Is number %2 equal to 0? No, number is odd. Stop.